Welcome to section 2 of this course. So now that we have a better understanding of the monolithic and microservice architectures, we will be looking at Amazon Web Service building blocks for creating serverless microservices. In this section, we are going to first look at virtual machines, containers, and serverless computing in the public cloud and provide a detailed comparison of all three approaches. Then we will cover in more detail serverless computing specifically in AWS. And finally, we will conclude this section on describing how you can set up your own serverless environment in AWS. In this video, we are going to talk about the virtual machines, containers, and serverless computing, which are the basic building blocks behind any application or service hosted in the public cloud. In this video, we are going to take a look at virtual machines, which are the original offering in the public cloud and web hosting sites, containers, which are much more lightweight standalone images, serverless computing, where the cloud provider fully manages the resources. You will understand the benefits and drawbacks of each approach, and we will end on a detailed comparison of all three. In traditional data centers, you would have to buy or lease physical machines and also have spare capacity to deal with additional web or user traffic. In the new world, virtual machines were one of the first public cloud offerings. You can think of it as similar to physical boxes where you can install an operating system, remotely connect via SSH or RDP, and install applications and services. I would say that virtual machines have been one of the key building blocks for startup companies to be successful. It gave them the ability to go to market with only small capital investments and to scale out with an increase in their web traffic and user volumes. This was something that previously only large organizations could afford, given the big upfront costs of physical hardware. So the advantages of virtual machines that you pay per usage, instant type and storage, giving your organization full flexibility to effectively hire hardware within minutes rather than buy physical hardware. Virtual machines also provide security, which is managed by the cloud provider. In addition, they provide multi-region, auto-scaling and load balancing, again managed by the cloud provider and available almost a button click. There are many virtual machines available, for example, Amazon EC2 or Azure VMs or Google Compute Engine. However, they do have some drawbacks. The main drawbacks are that it scales within minutes, so any machine that needs to be spun up does take a few minutes, making it impossible almost to scale upon requests immediately. There is also an effort in terms of configuration, where the likes of Chef or Puppet are required for configuration management, as well as the additional overhead of maintenance. For example, the operating system needs to be kept up to date. There is also an integration effort with the managed services, so you still need to write the logic to actually poll or subscribe to other managed services, such as streaming analytics services, for example. In addition, you still pay for idle machine time. For example, when your services are not running, the virtual machines are still up and you're actually still paying for that time even if they're not being actively used. Containers. The old way with virtual machines was to deploy your applications on a host operating system with a configuration management tool such as Chef or Puppet. This has the advantage, as I said earlier, of entangling the application artifacts, libraries, and lifecycles with each other, and tying you to specific operating system, whether Linux or Windows. So containers came out of this with the idea of shipping your code and dependencies into a portable container, where you have full operating system level virtualization. You have better use also of the available resources on the machine. These containers can be spun up very fast, and they are effectively immutable, so all the changes within that container is immutable and can be reused. So the basic idea is that you ship the code and dependencies in this portable container, and the environments can be recreated locally or on the server via configuration. Another important aspect is the orchestration engine. This is the key to managing containers. So you would have Docker images that will be managed by the likes of Amazon EC2 Container Service or the Kubernetes service, which is newly introduced in the Amazon world, along with Fargate. The drawbacks are that these containers still scale within seconds, which is still too slow to actually invoke a new container per request, so you'd need them to be pre-warmed or already available. In addition, the cluster and image configuration does involve some effort. At the reInvent in December 2017, Fargate and Elastic Kubernetes Service got introduced, which helped relieve some of this effort management, but it still needs to be considered and configured. The other drawbacks is that there's an integration effort with the managed services. So for example, if you're dealing with a streaming analytics service, you still need to write the polling and subscription code in order to pull the data almost into your application or service. Finally, in addition, similar to the virtual machines, you still pay for any containers that are running within, they can run on the EC2 instance, so you'll still need to pay for that actual machine for running time, even if it's not being used. Serverless computing. So you can think of serverless computing as the focus on business logic rather than focusing on all the infrastructure configuration management around the service. So in the service computing, there's still servers. It's just that you don't manage the actual servers themselves or the operating system or the hardware, and all the scalability is actually managed by the cloud provider. So that includes you don't have access to the raw machine, so you can't SSH onto the box, for example. So the benefits are that you can really focus on the business logic code rather than any of the infrastructure, which is the business value that you're adding actually to your customers and clients. In addition, the security is managed by the cloud provider again. Auto scaling and the high availability options are also managed by the cloud provider. So again, you can spin up more instances dynamically based on the number of requests, for example. We'll talk about those in a minute. And also the cost is per execution time, not per idle time. So for example, there's different offerings in different public clouds. So in Google, Azure, or AWS, or Alibaba Cloud, we have this concept of functions as a service. So this is where you just deploy your business logic code within a function, and everything else around it, the security, the scalability, is managed by the cloud provider. The drawbacks are that these are stateless, which means they have a very short lifetime. After that is within a few minutes is over, then any state maintained within that function is lost. So it has to be persisted outside. So it's not suitable for long-running processes, for example. It does have a limited instance type and a duration. For example, the lambdas have a duration of 5 minutes to maximum in the AWS world. There's also limitations, since these lambdas need to be spun up very quickly on the actual size of the external libraries or any custom libraries that you package together. So here I've got a comparison between infrastructure as a service, containers as a service, and functions as a service. So those were the 3 previous slides that we just described. Infrastructure as a service, you could think of it as the virtual machines. Containers as a service we talked about, for example, the Docker containers, and functions as a service would be an example would be Lambda functions. So we have a comparison here where we show the green elements, user managed, and the blue are cloud service provider managed. So on the left, you can see that infrastructure as a service used with virtual machines, a lot of the responsibility is actually on the user. Container as a service, the operating system level is managed by the provider, but you can see that the container and the runtime are actually managed by the user. And finally on the right, functions as a service, you can see just the core business logic, code and application configuration is actually managed by the user. So how do you choose between AWS Lambda, containers and EC2 instances in the AWS world? It's very simple. So if we compare virtual machines against containers and Lambda functions on the top row, you can see that there is some configuration effort required in terms of the maintenance, building it for high availability and configuration management. For the Lambda functions, this is actually done on a request basis. So it's request driven. Your Lambda will spin up more Lambdas if more traffic hits your site or you get more users. In terms of flexibility, you have full flexibility in virtual machines and containers, but in the Lambda world, you have default hardware, default operating system. Upside is that there's no maintenance required on your side. In terms of scalability, again, you need to plan ahead for virtual machines and containers. So you need to provision the containers or instances and decide how you're going to scale. In AWS Lambda functions as a service, this is implicit. Based on the number of requests, you will get more Lambdas executing in parallel. The launch time and lifetime for virtual machines is usually minutes, and they can stay on for weeks perhaps. For containers, they can spin up within seconds, and they can stay on maybe for minutes or hours before they can be disposed or recycled. Lambda functions, however, they can spin up within a few milliseconds and generally live for seconds or maybe a few minutes. In terms of state, so virtual machines and containers can maintain state. Lambda functions are always stateless. At the end of the life, anything in memory is disposed unless it's persisted outside into a data store or to S3, for example. Integration. So AWS integration for virtual machines and EC2 instances is custom integration. Lambda functions, however, can actually push data to you. They have a built-in integration with the other AWS services such as Kinesis, S3, API Gateway. So all you have to do is actually subscribe to a Kinesis stream and the data will get pushed to your business logic code where you can decide how you process and analyze that data. However, for virtual machines and EC2 containers, you need to build that custom logic using the AWS SDK or some other means. Finally, in terms of pricing, EC2 instances are priced per second. They also have a spot instance, which is using market rates, which is a lot cheaper than on-demand instances. And this goes the same for containers, except that you can have many containers on one EC2 instance. So this is very interesting also, a lot cheaper, and you can spread the load of containers amongst the EC2 instances. Finally, for AWS Lambda functions, the pricing is per 100 milliseconds, invocation number, and also the amount of RAM or read access memory required.